Hi everyone and welcome back to PrepFusion. I'm Anish and today we'll start the first lecture of mathematics foundation of gate. Okay, so today we will be discussing about the wavy curve method. This will be the first topic. After this we'll discuss about functions and graphical transformations and so on. Okay, so this video, right, everybody can watch. Even if you are good at mathematics, then also you can watch, because I think many of you guys skip this concept, and this concept is used in multiple places, okay, in our subjects. And I have seen doubt from multiple students on this concept, right? Because whenever it will get used in other subjects, you will not be able to understand that concept. Okay, so we will study with wavy curve method. So what is basically wavy curve method? Before understanding that, wavy curve method is mainly used, it is mainly used to solve inequalities. So I hope you know what are inequalities. Inequalities are this, right? Which doesn't exactly say that it is equals to something, x is equals to something, or it specifies a condition. Condition is x is greater than equals to 3, or x is greater than or x is less than equals to minus of 3. It has some conditions. So these are known as inequalities. So we have mainly four types of inequalities. One is greater than, another one is less than, then greater than, less than, greater than equals to, or less than equals to. So these are the four types of inequalities that we know. So we will solve few inequalities. I know you know this, and I think you can solve this in a second, but we will go to the next level. Trust me, at the end of this lecture, after, like, if you just see the question, right, before even watching the lecture, if you see the question, you will be scared, but after watching this complete lecture, you will be able to simply solve the question. You will not be scared by seeing the question. Okay, so these are few basic things. Let's solve this inequality. First inequality is, we have to solve 2x minus 6 is greater than 10. So how will you solve the inequality? So what is the method? I know many of you guys use the shortcut that you move this minus 6 on the right hand side. If you move this minus 6 on the right hand side, it becomes plus 6. But actually what we do, actually what we follow, actually what we do is we add 6 on both sides. So this will be same. Okay, this equation will be same. What we do is to remove this minus 6, because I want to keep x separate. So what we have to do, we have to keep the x separate. To separate the x, I will add 6 on both sides. Okay, I will add 6 on both sides, plus 6. Okay, so it becomes 2x is greater than 16. So if I add 6 on both sides, I get 2x is greater than 16. Now what I will do is I will divide by 2 on both sides. It's not like I'm like taking this 2 and dividing here. No, what we actually what is the process is we divide by 2 on both sides. So what I will do is I will divide by 2. I will keep this as same, and then I will divide by 2. Now if I divide by 2 on both sides, I get my actual answer, that is x is greater than 8. Okay, so this is the inequality that we'll find. This is the condition for x. So we have to solve for x. So they will give you some equation, and we have to find out the value of x for which it will satisfy this inequality. So you choose any value greater than 8, this will always satisfy the inequality. If you choose any value less than 8, this will not satisfy. This inequality will not be satisfied. Okay, so that is what we actually do. So here, right, now I will not use these steps. We made few shortcuts. Actually we were doing adding 6 on both sides, but what we generally do is we take this 2 on the right hand side, so this sign changes. That is what you think you're doing, but actually you are subtracting 2 on both sides. But as we have developed a shortcut, so we will use the shortcut only. That I will directly now solve. This will be 3x 8 minus 2, then it will be x divided by 6 divided by 3. So x has to be greater than equals to 2. So this is pretty simple, no problem with it. Another thing is that whenever this x greater than 8, what region does it specify? Basically, if you want to show graphically, what you can do, you can draw the number line. If I draw the number line, x greater than 8, let me mark the point 8. Okay, this is the point 8. This is a real number line. So x greater than 8 represents this region, right? Whenever my x is greater than 8, so this left hand region is the negative region. What about this x greater than 2? This will be here. My 2 is here, and this is my x greater than 2 region. Okay, so yeah, I hope you understood these points. Let us solve the last one. Now last one has a bit of twist in it. So what twist does the last one have? So if I solve the last one, so here it will be, just you have to be careful. I will take this minus 6, I will take this 16 on the right hand side. So this is with plus sign, so this will become minus sign here. So it will be minus 5x greater than equals to 21 minus 16. Okay, so and then what it will write, you will divide by minus 5 on both sides. If I divide by minus 5, this will be 5, and if I divide by minus 5 on both sides, this will be minus 1. Okay, so what you will get, you will get your result to be greater than minus 1. Okay, and this will be wrong. This will be wrong. This will be totally wrong. Why this will be wrong? Because you didn't take into account the negative sign. Whenever we divide by a positive number or divide by or multiply by a positive number, inequality doesn't change. But whenever we divide or multiply by a negative number, inequality has to change. So actually what should have happened is, when I am dividing by minus 5, right, this will be, inequality will change. This will be minus 1. Inequality will change. Inequality will change. Now obviously I will explain why inequality will change. I will explain that, and I will explain with another method as well to not change the inequality and get the same result. Okay, first of all, is 5 greater than 3? You will say yes sir, 5 is greater than 3. Now if I multiply minus 1 on both sides, this will be minus of 5 and this will be minus of 3. Now tell me which is greater and which is lower. You will say, sir, it is very simple, right? Minus 3 is greater than minus 5. So obviously inequality sign will be something like this. Minus 3 is greater than minus 5. So if you notice, you knew this in your mind that yes, by default you knew this, the sign of inequality will change. That's why you told me, right? Minus 3 is greater than minus 5. But when you come to inequality and directly multiply minus sign, it doesn't come to you intuitively. So basically what you have to understand is this 5 and 3. So whenever I multiply or divide by negative sign, right, the sign of inequality will always change. Because in negative, things are opposite. Minus 3 will be greater than minus 5. In positive, 5 will be greater than 3, right? So you have to take care of the sign of inequality. Now, what other way I could have solved this? So instead of dividing by minus 5, right, what I could have done is make this coefficient positive. How will I make this coefficient positive? So method 2 will be, I will reach up until this equation, that is minus 5 x is greater than equals to 5. Now what I will do is, I will take this whole thing on the right hand side and I will take this whole thing on the left hand side. So this sign will change and this sign will also change. So this will be greater than equals to minus 5 and 5x. Okay, so my x will be less than equals to minus 1. So without even dividing by negative number or something, I divided by positive number only, so inequality sign remain intact, but I got the same answer. Okay, so this is how you solve basic inequalities. We have just touched the surface level. We haven't even started the actual lecture. Okay, so one more thing is that we also represent, like mathematically, how will you represent this region? This is going until infinity, right? For infinite number of values, this will satisfy. So mathematically, how we used to represent x greater than 8 is, our x belongs to values beyond 8 to infinity. Okay, and these are what? Open brackets. These are called open brackets. Don't worry, I will explain this. We have a slide for this. I will explain about open brackets, close brackets. I know you have a bit of confusion. Okay, open brackets mean it does not include the value 8 and infinity. Why it does not include? Because here I have greater than 10. If I put x equals to 8 here, it will be exactly equals to 10, but I don't want that value. I want this inequality to satisfy. When will this inequality satisfy? This inequality will satisfy only when my x is greater than 8. If my x is exactly equal to 8, this will be 10, right? And 10 is equal to 10. It is not greater than 10. So this inequality will not satisfy. If I choose 10.1, even if we choose 10.1, 10.0001, 10.0001, then this inequality will be satisfied. But 10 will not be satisfied. Okay. So that's why, I mean 8.0001, 8.0001, those values if you take, this inequality will be satisfied. But if you choose 8, this inequality will never be satisfied, right? 10 will be equal to 10. So I cannot choose 8. Anything just above 8 I can choose. That's why we represent it with open bracket. 8 is not included, but everything after 8 is included. And infinity, right? Infinity is just a feeling. Infinity is just a feeling. Okay? It is not actually, it is not a real quantity, because we can never quantify infinity. Infinity is going, like, it is a increasing number, right? We cannot quantify infinity. That's why it is just a feeling. We cannot exactly say infinity is equal to some value. So that's why infinity is also open bracket, because we can never reach infinity. Okay, that is the reason. So that is how we like mention our x range. The questions will be given like this. Don't worry, I will discuss about this just in the next few slides. Here also x is greater than equals to 2, then your x will belong to 2 to 8, but not 2 to 8, so 2 to infinity. But remember here, right, it is greater than equals to, so I have a greater than equals to sign, so x can be equals to 2 as well. Whenever I will have equals to 2, that means that value 2 is included. If the value 2 is included, we represent it by close brackets, and in the graph we make a huge point here. Point means the two values included. Okay, if point was not there, that means 2 value is not included, it is excluded. But here 2 is included, because if I put 2 here, right, then this inequality will satisfy. If I put 2, then it says 6 plus 2, that is 8. 8 is equals to 8, which it satisfies, because I have a equal to sign here as well. So it will satisfy the inequality. Okay, so this is the case for these kinds of inequalities. Okay, now let's solve for this region. So here my x is less than or equals to minus 10 in minus 1. In the number line, what region am I located at? In the number line, I'm simply located in this region, right? Minus 1. So this is the region that I am located in. And is minus 1 included? Yes, because here if I put minus 1, here we have equality side. If I put minus 1, this will be minus 21, and minus 21 is equals to minus 21, which is satisfying this inequality. So minus 21 is also included, minus 1 is also included, so I will put a dot here. If it was not included, right, I should have, I generally, that is my convention, it is nothing fixed, it's just my convention. If 8 is not included, right, so what, I put an open circle, okay, hollow circle. And if like this here, minus 1 is included, I put a closed circle. Okay, solid circle. So how will you represent in mathematical terms? So x will belong to any number that is less than minus 1, and it is including minus 1. So I will start with a square bracket, minus 1, and it will go until minus infinity. So like generally we start from lower to higher. That's why I written the lowest value first, then the higher value. Okay, that is the convention of how we write the values. Okay, obviously we can never touch minus infinity. That's why it is in the open brackets. Okay, so like now we will discuss about the intervals. So these are known as intervals on where x belongs to. There are mainly 3 types of intervals that we can define. Okay, like with this you can have more combinations, but this, right, are mainly these are the main types of intervals. You can have combinations in between. So types of intervals are one open interval, closed interval, and semi open and semi closed interval. So open interval means where if x is between a and b, so x can be written as x belongs to this sign, right? Is this sign the physical the what do you say, meaning of this sign is belongs to, x belongs to this values. So x belongs to a comma b. Okay, that means a, between a and b I can give any value for x, right? So let's say x belongs to 1, 3. So between 1 and 3 I can choose any value, 1.001, 1.001, 1.01, 1.00001. Okay, I can choose any value, or 2.9999, 2.99998, any value. But I cannot choose 3, or I cannot choose 1. So that's why I have represented in the number line with open circles here, because the exact value of a and b are not included. Okay, same like in the closed interval. In the closed interval, the difference will be now a and b, it is also equals to a and b, so a and b are included, so I just included a closed circle here, right? A solid circle. So how we represent here? We represent it with open brackets, okay, round brackets, and here we represent it with square brackets, okay, because they are included. So if a value is included, we write it with square brackets. Okay, now what is semi open and semi closed? Basically, one limit will be included, another limit will not be included. So if something like that happens, like x is greater than a but it is less than or equals to b, so b is included, so we represent b with closed brackets, and a is not included, so we represent a with a open bracket. Very simple and very easy to understand. Now there is another type of thing as well. If a single number is included, let's say I have a number line, okay, and this is c. If a single number is included, then we represent x belongs to c with curly braces. These are known as curly braces. If x belongs to a single value, then we represent it with curly braces or curly brackets. Okay, if it only represents a single value on the number line, let's say x is equals to 6, okay, then 6, right, will be represented like this. Okay, so I hope you understood the types of intervals. Now there are few operations on intervals that we need to understand before coming to the main topic of Wavy curve method. So here, if you see, few operations of intervals are there. First one is union, second is intersection. You already know this, but still with the example I will show you. What does this mean? X union 1 comma 4, x belongs to 1 comma 4 union 2 comma 6. Include everything. Whatever is written, include everything. That is what union means. Combines all value. That means include everything. So in the number line, how will I represent it? So they are telling me that I have x equal to 1 point, x equal to 2 point, x equal to 4, and x equal to 6. Now they are telling me one of the region is telling me that x belongs to 2 to 6. So 2 to 6 is here. And another region is telling me x belongs to 1 to 4. 1 to 4 is here. Okay. One to 4 is here. So actually what my x belongs to, which region does my x belong to? Actually this is a 1D line only. To explain to you, that's why I have drawn this 2D. This is a 1D line. Okay, 1D line we should explain it, but you cannot understand it in 1D, so I will explain in 2D. So first region is telling me I belong here, second region is telling me I belong here. Okay, so union, what union will do is take everything whatever is shaded, take everything whatever is shaded. So ultimately in the number line, if you want to draw cleanly, my x will belong to 1 to 6. It will include everything, right? Everything is included, so x will belong to ultimately 1 to 6. Whatever colors are shaded, I'll shade. So this region is also included, this region is also included. Common region also I will take everything. Okay, so ultimately I can simplify this expression. Like this. X belongs to 1 and 6. Obviously 1 and 6 are included because I have square brackets here. Okay, square brackets. Here, what is intersection? Let me take the same example. 1 for intersection 2 6. Now what difference I will be? I will only take the common values. What are the common values for these two regions? The common region is only this, right? Between 2 to 4. Between 2 to 4, I have only common region. Is 2 and 4 included? Yes. Here 2 is included. Here 4 is included. So 2 and 4 both are included. So my common region will be only this region. So for this case, for the intersection case, the drawing will be something like this. This is my 1, this is my 2, this is my 4, this is my 6. Okay, so I am lying between 2 and 4. Okay, very simple, very easy to understand. Okay, so yeah, that is basically it. So here, how will I write it? So I will write x belongs to 2 to 4. Okay, so this is where my x belongs to. It's very simple. So these are few operations on interval that you should learn. Okay, now we will solve few inequalities or polynomial inequalities. So now we will solve with polynomial inequalities. these are known as polynomial inequalities. Okay, so what are polynomial inequalities? So we have to find the value of x, solve the inequality. We have to solve the value of inequality for x. I should have written here for x. So what is the values of x for which this inequality will satisfy in the options that asking me, right? So whenever these kind of things come, right, let us take an example. Okay, let us choose few value. So I am observing whenever a polynomial inequality will come, first you write the critical points. Okay, first, what are the critical points? Critical points at which this value is going to 0, those will be my critical points. So I can clearly observe that x equal to 5 is a critical point where this whole polynomial is going to 0. So I will write x equal to 5. And x equal to 3 is also a critical point for which it is going to 0. Okay. Now, the interesting fact, choose few values greater than 5, choose few values less than 5, and choose few values between 3 and 5. So you got your 3 regions, region A, region B, region C. Let us first discuss about region A. So if I discuss about region A, I can choose any value less than 3, right? So let me choose as 2. If I choose 2, what do I observe? 2 minus 3 is negative, that is minus 1, and 2 minus 5 is also negative, that is minus 3. Minus 1 into minus 3 is plus 3. So I get something positive on the left hand side, and I need on the right hand side I have 0. So is it satisfying the inequality? Yes, it is satisfying the inequality. Okay, so I'm satisfying the inequality. Obviously, then x equal to 2 is a valid point for this inequality to satisfy. Okay, you can choose another value. So I can say that overall I'm getting greater than 0. If I choose, let's say if I choose 1, again you will see I'm getting greater than 0. Let us choose region B. Now if I choose region B, in region B, what I have? Any value between 3 and 5. I will choose 4. If I choose 4, what is the expression? Expression is positive or negative. So this, right, you can write this as f of x. Okay, f of x. So here I can write, like to properly explain, my f of x will be greater than 0. Here also my f of x will be greater than 0. Okay. Now, what is this? In between 3 and 4. So let me choose a value 4. If I choose 4, this will be 4 minus 3. So this is positive, but this is 4 minus 5. This is negative. So 1 into minus 1 is negative. So my f of x is going negative, right? So it will be negative. F of x is negative. You choose any other value. You can choose 4.5. You will see again your f of x will be negative only. Okay. And coming to the last region, region C. In the region C, choose any value greater than 5. So I will choose 6. So if I choose 6, you will observe that your f of x will be greater than 0. If you choose 7 as well, your f of x will be greater than 0. So what is actually happening? What is actually happening? So in each region, the signs don't change. That means between each critical points, the signs don't change. So once I cross over this critical point, right, the sign will remain same. Okay, you can choose any value. You can take more examples. So we say that x greater than 5 is positive, x less than 3 is positive, between 3 and 5 it is negative. So to represent this, we actually plot a wavy curve. That's why the name wavy curve came. Okay, that's why the name wavy curve came. So how do we represent? We represent it like something like this. So it is positive, negative, just hold on, positive and negative. So between this region it is always negative, in this region it is always positive, in this region it is always positive. And if you choose, why have I drawn this wavy curve like this? Because it is also telling me what is the magnitude. At x equal to 5, right, it is equal to 0. You put x equal to 5, it will be equal to 0. At x equal to 3 also, this is equal to 0. Okay, this is my f of x. Now this is not exact graph of f of x. I'm just plotting the signs, and this is just signs. Okay, this is not discussing about the exact graph of f of x, and also sign and 0, where my function will go to 0. These two things only our wavy curve can show. It cannot show the exact graph of the function. Okay, that we'll learn in the next lecture. Don't worry about that. So I hope you understood this point, right? Now uh, this is the basic point that you need to understand. Now we will build upon this. So now tell me which region satisfies the inequality. I need my f of x to be greater than 0. When, in which regions is my f of x greater than 0, greater than 5 or less than 3? These are the two regions. So my x, right? My x will either be greater than 5 or uh, less than 3. So basically, what is the steps? Steps is first mark the critical points on the number line. What are the critical points where my f of x is equals to 0? How will I know where my f of x is equals to 0? Simply factorize the expression. Don't worry, we'll solve few more examples. We'll understand what do we mean by factorize, and make the right hand side to be equals to 0. Right hand side must be equal to 0, right? Because that is what my critical point is. That is exactly equals to the value at which it is going to 0. So right hand side must be equal to 0. One point. Second point is you have to factorize. These are the 2 points only that you need to take care of. Okay. Then after marking, you will draw the wavy curve. Draw the first. You will mark the regions. Mark the regions. Then what you will do? You will draw the wavy curve. Okay. After drawing the wavy curve according to the signs, with signs obviously, with proper signs, okay, we'll see few examples. After drawing the wavy curve, you select the regions that satisfy uh, your inequality. So what is satisfying our inequality here? If I observe carefully, I need something positive. F of x must be positive, so I need to choose this region or this region. So basically, my my x x can belong to, okay, first I will choose the lower limits. It can belong to minus infinity, right? It can belong to minus infinity because minus infinity is included. I mean, minus infinity is a like valid region, okay, and until 3, right? After 3 it is going to negative, so I don't want that. That is not included, and my 3 also will not be included because 3 at 3 it is going to 0, and I have only greater than sign, so obviously 3 will not be included here, okay. And union, why union? Because this region we have to also include. It's not like we have to include the common region. This region is also possible where my inequality is satisfying, so I can include this. So that's why union sign, okay, it has to be greater than 5. So if it has to be greater than 5, so it will be from 5 is not included again because we don't have a equal to sign to infinity. So these are two valid regions. Now let's solve few more examples. So we will brush up on this concept. So let's solve this inequality for x. Okay. So we have x into x square minus 4 less than equals to 4. Now it's very simple, right? Now you don't know the critical points exactly, okay, because I cannot directly say what values of, for what values of x it will go to 0. I know plus 2 is a valid value, but minus 2 also is, right? So first you have to factorize this. So to factorize, you break it into like terms. So this will be x minus 2 into x plus 2, okay, less than equals to 0. Okay, so these are the values. Now can you say, can you draw the wavy curve? Yes, it's very simple, right? First of all, I will mark the critical points. Critical points, one is at -2, another one is at 0, another one is at 2. Okay, now I will write the signs. You just choose a value. You choose a value. If I choose x greater than 2, what I see, this is positive, this is positive, this is positive, everything is positive. If everything is positive, so any value x greater than 2 will always be positive. So I will always have positive here. Now if I choose any value between 2 and 0, you will see you are getting a negative. Overall your f of x will be negative. Another point, key point is, between a critical point, right, sign change happens. But this point I will revise, this point I will tweak, because there is a caveat, there is a condition to it that I will add at the end. For now, just understand, after every time I pass a critical point, the sign will change. So here the sign will be negative, okay, here the sign will be positive, here the sign will be negative. I can directly write without even solving for the values. Okay, so here it will be positive, it will be negative, it will be positive, and it will be negative. Okay, so this is the case. Okay, and also I have to include the points, critical points as well, because it is where the values is going to 0 and I have equality sign. So I have to include this value. That's why I put a dot here to signify that yes, I will include this in my answer. This also will be included in my answer. So now what is my region of interest? My region of interest is negative, because I am less than or equal to 0. So this is my region of interest. This is my region of interest. So first of all, I will write the limits. Okay, so obviously I will start from the lowest one. Lowest is minus infinity. Okay, then I come to -2, and -2 is also included in the region because it has a equality sign. So -2 will be there with the equality sign. Then union, this has to also be included, right, between 0 to 2. So this will be between like 0 also will be included, and 2 also will be included. Okay, these will be my region. This will be my inequality. So option here, option B will be correct. In the previous question, I think I forgot to mark the option. Okay, I will mark the option previous question. Yes, I forgot to mark. So what region we solved? We solved minus infinity to 3. Minus infinity to 3 and 5 to infinity. Okay, so this will be the region, because they have shown with square brackets as well, but square brackets will not be the answer in the previous question, because this critical points were never included because I didn't have a equality sign here. Okay, so this is how solved. Like I have shown you, like breaking down what each signs are for each expression and then solving. Okay, you can go through this in the PDF. PDF will be present in the Telegram group. Okay, now let's solve a bit different kind of question. So we have to solve the inequality. This is in factorized format, but one thing is different. This is 2 minus x and not x minus 2. So will anything change in our answer? We'll see. So again, I will write the critical points. What are the critical points? This is already in the factorized format. So my critical points will be at x equal to 2 and x equal to 5. Okay, so these are my critical points. Now let's choose few values. If I choose a value x greater than 2, x greater than 5, what will you get? This will be positive. Let's choose 6. This will be 1. This will be what? This will be minus of 4. So I'm getting something negative. So now things are becoming a bit different. So now I am getting a negative number, not positive. Every time whenever we solved, I always got a positive number at the right hand side. What changed? What changed? This change, right? This minus sign with x. So you don't have to take a stress. Just derive the sign for one of the regions, and in the other regions automatically, after every critical point I pass, the signs will change. Of course, there is a note to this. There is a small thing that I want to add on this rule, that I will add just after a few slides. Don't worry about this. Okay, just in the next slide itself. Okay, don't worry. But for now, you understand, at every critical point the sign will change. So you just write the sign for one of the regions, and the other signs will automatically you will get by just changing the signs. So this will be, so this will not be positive, this will be negative, this will be positive, this will be negative. Okay, so basically my wavy curve will be something like this. Okay, so this is the wavy curve. Just hold on a second. Just hold on a second. Yeah. So now let me solve for the inequality. What region I need? My region of interest is positive. My f of x should be positive. So positive is this my region of interest. And is it included? No, there is no inequality. There is no equality sign. So 2 and 5 will not be included. So basically, my x will belong to 2 comma 5. Okay, this is the region of interest. This is the region of interest. So I got my answers. Okay, now uh, like what thing, like what other way you could have solved if you didn't like this method, right? If you didn't like this method, then what you can do is there is another method. Like here I have told you what are the signs of inequalities and all those things, but there is another method. What is the method 2? What is the method 2? First I will write down the inequality. Inequality is 2 minus x into x minus 5. It was, right? X minus 5, it has to be positive. Okay, that was my inequality, correct? Yes. So now what we will do is we will basically, we don't like this format. We want to write in our format, that is coefficient of x should always be positive. So what we will do, I will change this. Okay, I will take common a minus sign. So this minus sign will be common. So it will be x minus 2 into x minus 5 greater than 0. Now I will multiply minus 1 on both sides. If I multiply minus 1 on both sides, what will happen? The sign of inequality will change. Why? I have explained at the starting of lecture. So this will be x minus 2 into x minus 5 less than 0. So the sign of inequality changes now. Sign of inequality changes. So now it becomes very, very, very simple. Okay, so it becomes very, very simple now. But the inequality also has changed, but the region of x will be not different, right? So if you, so that you don't get confused, I generally don't prefer this method, but I have to teach you everything, right? So I'll teach you everything. Now we have to solve for this new inequality. This is a new inequality, okay, that we have to satisfy, but this is in the format of our standard form. Now I will mark the critical points. What are the critical points? The critical points are 2 and 5 again. But if you see, right, for x greater than 5, I'm always getting positive values. Now this is my f dash of x, like, or my new f2 of x. Okay, new function. This is not the previous function. But the region of x I will get same. This will be plus. This will be minus. This will be plus. But what do I need to, what is my region of interest? My region of interest this time is negative. I need the value to be negative. Negative is in this region, right? And 2 and 5 will obviously not include it because equality sign is not there. So my actual region will be x between 2 and 5. So I'm getting the same answer. Here also I'm getting the same answer. Here also I'm getting the same answer, x between 2 and 5. But this is the original inequality. But I converted this inequality into my standard format and then solve. So you can solve using this if you are not comfortable with negative signs. But I will not prefer this. You will get confused. It's better to just solve using this method. Okay. But both will yield you the same answer. Nothing is changing. We are not doing anything. We are just manipulating the numbers and the function on the left hand side. That's what we're doing to convert in our standard format. Okay. So now we'll come with the type 3 of these type of questions, where what we do is, on the right hand side I don't have a 0. I told you, right, at the starting of this wavy curve, that you have to make them 0. You have to make them 0. So even if this is not 0, I have to make it 0. So I will subtract now 6 on both sides. So my equation, this will become solve for x. So my x square minus 5x minus 6 is greater than equal to 0. Now I will factorize. If I factorize, this will be x minus x plus 1 into x minus 6 greater than equals to 0. Okay. So these are the value of inequalities. So now what you can do is, now you satisfy. You convert it into a standard format. Now you satisfy. Now you write down the critical points. What are the critical points? Critical points are minus 1 and 6. So critical points are minus 1 and 6. Okay. These are my critical points. This is my minus 1 and this is my 6. Now obviously 6 and minus 1 are also included. So I'll put a circle. Okay. And I need to choose, again, this is in the standard format. So if I choose any value, so what I will recommend is just choose any value, any region, okay, then find out the sign, and from there you can derive the other signs. You don't have to worry about what is the coefficient of x, what is that, right? That is my recommendation. So I will choose a value that is 7. If I choose 7, this will be positive, this will be positive. So overall, in this region, I will get a positive value that is greater than 6. And then after passing its critical point, the signs will simply change, right? So this will be simply negative, this will be again positive. After passing every critical point, the signs will change. That is what we know. There is a bit of modification in this rule. I will discuss about that. Okay, so the region of interest will be equals to and greater than this, right? Positive. So this is my region of interest and this is also my region of interest. So x will simply belong to minus infinity to minus 1 union it will belong to 6 to positive infinity. Okay, so this is my region of interest, so this will be my answer. C will be my answer. Okay, and the previous question I mark the, okay, I forgot to mark the points. So here my answer is 2 to 5, right? So it will be 2 to 5, so A will be my answer. Okay, and like here they have like given you what are the critical points, how does the sign change, all those things they have given you. Okay, you can see this, but obviously I have explained the theory. Now we'll come to the type 4 of these type of questions. Okay, now it is in factorized format, but what do I see? I see a repeated root. I see a repeated root. Root means I see repeated critical points. Minus 1, this is getting 0 twice. Okay, so will anything change here? Yes, something will change here. Okay, what will change? I will discuss about that. First of all, let me write the critical points. Critical points are at x equals to minus 2, x equals to 1, and x equals to 5. These are my critical points. Okay, now what do you need to understand? Let me solve for any value x greater than 5. If I choose 6, right, this will be positive. This is square, right? This will always be positive. No matter what value I'll choose, this, if x is real, this will always be positive. If I square any number, this will always be positive. So I don't care. Okay, this will be positive. So this region is positive. X greater than 5. Now what about the region between 1 and 5? If I choose between 1 and 5, right, let me choose a number 2. If I choose a number 2, this is 1, this will be always positive. I don't have to think about this. This will be negative and this will be positive. So overall, I will get a negative number. Okay, now let me choose a value that is between minus 2 and 1. If I choose, just hold on a second, I will see everything, if everything is recording or not. Just 1 second, give me 1 second. Yes, everything is recording. So if I choose a value between minus 2 and 1, what will happen? Let's take the value 0. If I choose 0, this will be positive, this will be positive always, this will be negative. So again here, right, I'm getting negative value. Sign is not changing here, sign is same. So why did the sign remain same? Why is the sign same? Sign is same because the critical point is getting repeated twice. So basically, whenever a factor of even power will come, sign no sign change. Now the rule is complete. Whenever a factor of odd power will come, sign will change. Sign change. Now the rule is complete. Okay, you can take more examples, more values. You can wish to do that. Okay, so basically what is happening is that here again sign will change. If you choose n value less than minus 2, right, this will be negative, this will be negative, this will be negative, this will be negative, and this is anyways positive. So overall you'll get a positive number. So at critical point where I am getting repeated factors, it depends on the power. If the power is even, then the sign will not change. Why? Minus 1 whole square is 1. That's why. I hope you understood that intuition. Okay. So what will happen here is, this will be 5, this will be negative, and again it will go towards 0, it will go towards very low value, then again it will be negative only. Okay, then again it will be positive. Another important point is there is equality sign. If there is equality sign, obviously I have to include the critical points. I have to include the critical points. So what is my region of interest? My region of interest is where this inequality is positive. So this is my region of interest, and this is my region of interest. So x will belong to minus infinity to minus 2, and minus 2 will also be included because I have a equality sign, and union, it will belong to 5 going towards infinity. Okay, and you will see that this option is not present anywhere, and you will mark this, but you missed a point. We have a equality sign. If equality sign is there, so this x equal to 1, right, this also will satisfy the equation. If I put x equal to 1, this left hand side is 0 and right hand side is already 0, and 0 is equal to 0, which is satisfying the inequality. So I have to include a single value, and how we used to include a single value? With curly braces. So this will be 1. That's a simple thing. This will simply be 1. Okay, so my answer will be option B in this case. Okay, so this is how you solve the wavy curve method. Okay, if I had a odd sign here, right, if I write here, actually what is the rule doing? If I first, you have to write in factorized format, and then if you write in the powers of the factors, right, this is x plus 2 raised to power 1, this is x minus 1 whole square, this is x minus 6, x minus 5 raised to power 1 greater than equals to 0. Okay, so here I'm seeing this is odd power, this is odd power, these are odd power, so signs will change. Okay, signs will change. Now this is even power, so sign will not change. Okay, even, so sign will not change. So you have to take care of the powers of the factors as well. How are the powers of the factor related? Okay, so like the intervals and regions, all those things are explained over here. You can go through this, you don't have to worry, you can go through this. Okay, so we'll delete this page. Now, like, just the steps are written, whatever I have explained in the lecture, the steps are written. You can go through the steps. I don't want to explain too much on the steps. We want to solve the final part of this lecture, that is solving rational inequalities. Rational inequalities. Now that is what I was talking at the starting of this lecture. You might get scared after watching this question, right, if you don't know anything about inequalities, but you have a bit of sign. So in rational inequalities, nothing changes. Nothing changes except removing the points where my denominator goes to 0. Okay, goes to 0. So you have to take care of this thing. Your denominator should never go to 0. Because anything finite upon 0, right, is undefined. That we'll understand in limits. Don't worry about that. Okay, so that is what you have to take care about this. And one more thing, that do not think that I will cross multiply on both sides. This whole denominator I will cross multiply. Just like if I have 1 by 6, I will cross multiply 1 by 6, 6 on both sides. So I will not have a fraction. Don't do it, because another thing is, don't cross multiply rational inequalities. Why am I not recommending you to not multiply rational inequalities, cross multiply? Because I cannot discuss about the sign, right? Because this, right, has many signs. If you observe carefully, for x greater than 2, this value, right, will be positive. x minus 2 whole cube will be positive. For x less than 2, this will be negative. So, and you know, whenever we multiply with a negative number, I have to change the sign of inequality. So I have to take care of all this while multiplying, right? Well, x greater than 2, this sign will be in negative, this sign will be positive. So that's a big headache. I don't want to do that. I don't want to do that. So you just simply solve. You don't need to cross multiply, do anything. Convert in the standard form and then simply solve it. I will explain. Okay, I will explain. So first, let me plot the critical points. Let me write the critical points. So critical points are, I will just copy this function. Why this whole thing is coming? I don't know. Some weird reason this whole thing is coming. Okay. Critical points, if you see, critical points are x equals to, wherever the factors are going to 0, x equal to minus 4, x equal to minus 3, x equals to 2, and this, right? Here for no real values. This has no real critical points because we are only discussing about real values of x. So no real values. So this, right, will not include no real values. This is always positive, right? This is always positive. You choose any value of x, any real number of any real value of x, this will always be positive. So only these are my critical points, and of course you can observe the degrees of the factors as well. So I will plot the critical points on the number line. One is at minus 3, one is at minus 1, another one is at 2. Okay, so one more important thing you have to note is, as I explained here, right, you have to remove the points where denominator goes to 0. Yes, this is a critical point, but my denominator is going to 0 on this critical point, right, at x equal to 2. So how will I mark it in the number line? I will mark it with a hollow circle. So if I mark it with a hollow circle, right, if I mark it with a hollow circle, what does it specify? It specifies basically 2 will never be included in my solution, because whenever I put x equal to 2, this will go to some undefined value, right, which I don't like. I don't like 0 in the denominator. And you also don't like zeros, right? In your bank balance or in your mark sheet, you don't also like zeros, right? But that is what we have to avoid. So we don't like zeros in the denominator. Okay, so we will not include this. That's why I have made a hollow circle here. Now let's understand the other portions. Okay, so this is basically, if I choose any value greater than 2, will this be always positive? Yes. This will be positive, this will be positive, this will be positive, this will be positive, everything will be positive. So this will always be positive. So my values will go like this. Okay, and to signify this 2 point, right, actually about x equal to 2, this is tending towards plus infinity and minus infinity. So just write of plus 2, this will tend towards plus infinity. How will you understand? Just put any value, right? You just put here x equals to 2.0001. You will see this is tending towards plus infinity. You can see that. You can observe. You just put in the calculator x equal to 2.001. You will see this is tending towards plus infinity. Very high value. And if you put any value x equal to 1.999, something like that, right, it will go towards minus infinity because the sign change is happening here. So the value will be something like this, right? It will be something like this. Okay, sign change is happening. Just to represent this sign change, I'm doing this. Okay, and obviously at x equal to minus 1, again it is touching 0 because this critical point is at the numerator. And will the sign change? Tell me, will the sign change? Tell me in the comments, will the sign change? No, the sign will not change, right? Why? Because this is a even power I have. So sign will not change as explained by the rules. So sign will not change. This will be still same negative only. Okay, again at x equal to minus 3, I have a critical point that is in the numerator, and this is a odd critical point. So this will be something like this. Okay, so this will also be negative. You can cross verify, choose any value, choose x equal to 2, you will get a negative result here, right? So what region of interest I need the region where this is positive. When this is positive in this region, this positive in this region. Is 2 included? 2 will never be included. Okay, and equality sign is also there. Of course I have to include the numerator critical points, because if I put x equal to minus 1, this will go to 0. So obviously this will satisfy. And if I put x equal to 3, numerator we don't have problems, right? X equal to 1 and x equal to 3 will be included. So this is going to 0. So those will be included. So my region of interest, I will start from the lowest values, that is from minus infinity to 3, where 3 is obviously minus 3 is obviously included. union, I will start with 2. But will 2 be included? No, 2 will not be included because it is at the denominator. So 2 will not be included and it will go until infinity. Okay, this will be my region of interest. Now, are you forgetting something? Yes, you are. You are forgetting this minus 1, right? Because I have inequality, just be careful. So minus 1 is also in my region of interest. So I have to include union minus 1, a single point, right? So here option C will be the correct answer of this question. I hope you understand why minus 1 is included, because minus 1 is at the numerator, right? So numerator also you have to include whenever it is going to 0, because I have a equality sign here. Now let's solve the final question of this today's lecture, right? This you try to solve. Again, how will you solve it? Don't cross multiply. I always have mentioned, right? Don't cross multiply. Don't cross multiply. Why? If I cross multiply, right, you have to choose between the regions. For x, if I cross multiply by x plus 1 and x plus 4, for x less than minus 1, this will be negative. For x less than minus 4, this will be negative. So I have to be careful. I have to be very, very careful regarding that. So I will not cross multiply. I will take this on the left hand side. If I take this on the left hand side, it will be x divided by x plus 4 minus 1 divided by x plus 1 less than equals to 0. So it will be x into x plus 1 minus x plus 4 divided by x plus 4 into x plus 1 less than equals to 0. So this will be converted into, what are the factors here? This is x square minus 4 divided by x plus 4 into x plus 1 less than equal to 0. So this can be converted into x minus 2 into x plus 2 divided by x plus 4 into x plus 1 greater than less than equal to 0. So now again I will write the critical points. What are the critical points? The critical points I will plot. The critical points are at x equals to minus 4, minus 2, minus 1 and 2. These are my 4 critical points, right? So, and which ones are not included? So these, right, this will be with hollow circle, minus 4 and minus 1, because these are at the denominator, and this will be with closed circle, plus 2 and minus 2, because these are at the numerator, and I have a equality sign here. Okay, so I'll mark the critical points. So this will be minus 4, minus 2, minus 1 and 2. This will be hollow circles and this will be closed circles. Okay, now if I plot, okay, there is everything has even power. If I plot this, right, so whenever I have a hollow circle, I will just draw a dashed line to represent that just left and right values are going to infinity. So here if I choose any value x greater than 2, right, everything will be positive, so that means I will get a plus here. So this will be plus. Okay, then just I am encountering a odd powered critical point, so my sign will of course change, and what will happen is it will go towards negative infinity, right? This will negative infinity, and just left hand side of minus 1 it will go towards positive infinity, and again my sign will change at minus 2, and again just on the right of minus 4 it will go towards negative infinity, plus minus plus, and again on the left of minus 4 it will go towards positive infinity, and it will remain at that, right? It will just remain at that value. Okay, plus. So my region of interest is the negative and equality region. So x equal to minus 2 and plus 2 will also be included. And what are the regions? And the negative regions. So negative regions, I will start from the left hand side. Negative region is starting from here, minus 4 to minus 2, and minus 4 is not included obviously due to the denominator. So minus 4 is not included. Minus 2 will also will be included though. Okay, because I have equality sign here. So positive I don't select. Minus 1 again will not be included. Okay, but 2 will be included because this is at the numerator. So 2 will be included. So this will be my answer. Minus 4 to minus 2, minus 1 to 2. Okay, minus 4 to minus 4, this will be answer. Then we don't have options, so this will be my answer of the question. Just understand the brackets as well, this also you have to understand. So this is how we end our first topic of mathematics foundation, that is wavy curve. I hope you have enjoyed this lecture. If you did, do hit the like button and don't forget to write in the comments below how you enjoyed and were your concepts clear or not. So we will start with the next lecture, that is functions and graphs. Until then, happy learning and all the best for your upcoming examinations.